This is not a very difficult thing. We just got to be careful about how you read it. Binomial distributions. Binomial distributions, we actually did some of the...
You're missing 22.
Yeah. You did this stuff when we were trying to do that binomial expansion. And I asked you for things like, what's the third term and so on. Where we had that value where you have your n choose r a to the whatever, I forgot the whole form, but you know, that whole mess of a thing that you guys just did, binomial expansion. Well, you can actually use that with probabilities for very basic style probabilities. Think of them along the lines of your answer, your only two possible answers are binary. You know what that means?
Binary?
Yeah, what's binary mean?
Two.
There's only two possible answers. Basically, yes or no.
One and two.
1 and zeros. And binary code is done up in ones and zeros. So they use the binomial distribution for binary style probability. Way we worked it third hour is that I showed them how it worked through and what it means. Don't overthink this, okay? When you're looking at probability experiments, this is kind of what we're starting to get into these next few days here, is using probability with experiments to try to model things and come up with formulas and stuff, and it's actually pretty cool. When you can reduce your experiment to just one of two solutions, or two possibilities. We look at this as what's called a binomial experiment. There's only two possibles. I like to think of it as a yes and no kind of question. There are going to be what are called n independent trials. It means how many times you're going to pick through something. Each trial has only two possible outcomes, a success or a failure. So for example, if you have a 20% success, what's your failure going to be? Good, it's just the complement. They're complements in one way. Success and failure are complementary. The probability of success is exactly the same no matter what trial you're on. It still holds through when you're looking at this subset of data, if you will. But this is going to be something, it's like I'm saying here, do not overthink this. This is very, very, very straightforward. What's going to be weird is the fact of using the binomial theorem to create your probabilities. We're going to create some histograms, using the calculators for all of it, and then looking at how you can, using binomial experiments kind of is one of the ways of figuring out what's the probability if you flip a coin. Thank you. If you flip a coin 25 times, what's the probability you're going to get 8 of those heads? Things like that.
Is head success or is tails?
It doesn't matter because they both have 50% success rate. See what I'm saying? But if you're looking at a multiple choice test like your final, there's what, 4 possibilities? Let's say there's 50 questions. What's the probability you get 20 of them right just by random guessing? This is how the binomial stuff can come in because it's either going to be success or failure. Okay, you can whittle that down to being success or failure for all of those. You have a 25% chance of being right each time, but you also have a 75% chance of being wrong each time. And you can go through and calculate these probabilities. It's very straightforward, okay? And I want to start it with kind of like a little experiment of our own. What do we got? 1, 2, 3, 6, 10, 13. We have 15 people in here. Okay? So I need you guys to put your heads down so we can be completely anonymous.
Okay.
And I'm going to ask you a question. The question will have a yes or a no response to it. Okay? No, it's just going to be, if you believe yes, I'll say if your answer is yes, raise your hand. If your answer is no, I'll count, and then we'll go there. So we have 3, 6, 8, 10, 15. Yep, okay, there's 15 people. So we should have 15 total responses. My question to you on this beautiful early afternoon, late morning, is, do you believe in UFOs? If you say yes, raise your hand now. Okay, if you say no, raise your hand now. There's no peeking! Throw something at you! Okay, Now, one of you didn't vote. It's really tough. I asked one thing to be done, and you can't do that. It's sad. Come on. So out of the 15 people we have,
I'm sure you guys can like figure it out.
out of the 15 people, 5 of you believed in UFOs.
Okay, I live like, not believe in, not you.
Why is asking UFOs?
I know flying saucers.
Well, they could be flying pigs for all I know. And I'm just, for math interpretation, I'm just going to go ahead and use 10 there. Okay?
Hey, put it in there, please.
I don't know, somebody on the wall. So, probability-wise, the fridge, yes. What does that work out to be for yeses?
1/3.
So 1/3, and this would be 2/3. So basically, you're looking at 0.33 and 0.67. Is that okay if I do it like that?
Yes.
Okay. So we have a probability of success if we believe in the UFOs being at 0.33, a probability of failure at 0.67. You all right on that? Now, it's ironic. In third hour, it was, just erase the numbers too.
10 and 15.
It was 10 and 15. It was 10 and 15 out of the 25. So 10.
25 people left.
I know. You have 15, so it's. I mean, really should only have 2 sections of this class. So they were at 40% and 60%. So it's all pretty close. If you put your 2 classes together, what we get? What? 15 out of 40? What's 15 out of 40? 5, 3/8. 375. So if we put them together, it's 0.375. This is really kind of crazy at this point because the reason I wanted to show you how success failure comes up is because I wanted to utilize an example they gave in the book. So this is the test that we just did is in the book, but what do you think the success rate was that the book gave? Percentage-wise for success, what do you think it is?
38.
37%. So the book actually uses the exact same example with a 37% success rate. As of right now, we're at 37.5% success rate.
And then 12 hours.
I want to see what happens in 12, how much it gets, if it gets skewed itself back. What's that?
How many people are in 12 hours?
I think there's 28 or 30. I think it's 30. It's a lunchtime one, so that's why. Yes, ma'am. I added your classes to third hour. So now when I go into this here, I'm going to switch gears and I'm going to utilize the 37% success rate that the book uses and walk you through how this is calculated when I ask the following question. The formula that we're going to use for probability of success on certain number of successes out of trials. Here's what that means. I'm going to take these 6 people right here. Okay. Just these 2 rows of 6 people. And that says that I have, out of n trials, I am checking 6 times, and I'm looking for a success rate of 2 successes that 2 people believed in UFOs. I'm looking to find the probability of our sample size in here that we found a percentage. We're going to use 37% because that's what the book does. So that way you guys can, if you got to go back and look at how they do this, use that number. Ours is really close anyway, but out of these guys here, what's going to be the probability that 2 of them believed in UFOs? Here's how you do that. We know that we're looking for this K value equal to 2. So we're going to say the probability that we have 2 successes. All right. I'm doing 6 trials because I'm picking 6 people to ask this question. I have 6. I'm choosing 2 of them because I want 2 successes. The probability of success in this case, like I was saying, is going to be 37%. So my p-value for this one is going to be 0.37. You okay with that?
Yeah, how do we find that number in other like
It'll be given. A lot of times it's gonna be given.
It's given,
Yeah, unless you have to sample and model it out yourself, okay? And that'll come from doing like coin flipping or something along those lines. It's very easy to calculate probability, okay?
So 0.3 squared.
Is it?
So now it's gonna be 0.37 squared. And what's failure then? Success and failure are complementary. I should say complementary, but they should add up to equal 1.
And then it's 4.
Has to be 4. Now remember our trick when we did binomial expansion. These two exponents have to add up to equal that one. Okay? This number here and this number will always be the same. And then these two numbers are always going to add up to equal this one. That was the trick when we dealt with binomial expansion. So if I put all this stuff together, I'm going to get a probability that 2 of these 6 in this sample, overall total sample, will leave UFOs. Calculator.
What if I just threw a calculator?
6, math, left, 3, 2. Point 37 squared times point 63 parentheses to the, oh, that's gonna be bad.
It's gonna be 0.334.
Yeah, these will be kind of annoying to type out because it takes a while.
And then I was going to go down, but I do actually.
So the probability that 2 out of these 6 believe in UFOs would be 0.32. I don't remember which ones you guys raised your hands for UFOs.
Let's do it again. I said.
Then you did.
I didn't.
I don't remember. Did you?
I said UFOs.
Okay, so did you?
Yeah.
All right, so pretty decent. We had 3 out of 1.
Now you get to argue.
Well, it's not an example.
You don't believe in UFOs?
Oh, let's ask.
Yeah.
So it's like throw
Hey,
throw a
Kelsey,
taco.
do you believe in UFOs?
I was trying to
I was trying to say.
Kelsey said no, just in case you're worried.
Good.
Congratulations.
What's our last name? Cooper.
Cooper. Okay? So what we're going to be able to do then with this kind of data is, like I said, we're going to jump exactly what they're going to do in the book now is same idea, but we're going to try and look at having 6 trials, and we're going to try and calculate all the different things that can happen. We're going to look at doing, we have 6 trials. We're going to sample up to 6 people. We're going to calculate the probabilities that none of them believe in UFOs. One person, 2, 3, 4, 5, and 6. So what we do is we create lists in our calculator. Okay? So what we're going to do is we're going to go a k value, k equals 0 to k equals 6 in list 1.
Alright, so 1 through 6.
So we're going to start at 0 through 6. Okay? And then on the other side, we're going to use this binomial formula to fill it in. It just takes a while to type in. That's really all it is. So let me pull this up on the next slide here.
Holy crap.
What we're doing here is these values are nothing more than starting at 0. So it's 620, 0.37 to the 0, 63 to the 6, and just putting that into your L, put this in your L2, okay? Don't calculate it and then put it in, just do the calculations in L2.
So is that the same like formula as like the expansion?
It is, it's the exact same thing. It's the exact same thing, okay? It is kind of gross, and it, like I said, it's just takes a minute or 2 to do. That's about it. Let's
And then you
see.
can just type it in like that into the calculator, right?
Yeah. So 6.
Oh my gosh. Now you need to like put parentheses around your 620.
You don't. 620, then you can put parentheses after that, it's gonna be okay. Point 37.
Raise to the zero. So we might as well stick to it.
Yeah, do we have to do that? I have a hankering for a bridge zero. Oh, that does sound so good. For what? Culver's bridges. I like bridge zero. Oh, I love that.
You have to be careful. You make one mistake, you're done.
I love apple cheese with goldfish. It's very underappreciated.
I never eat like grilled cheese.
Ah, I screwed something up.
You know, calculator should really make a function where if you like type in two of them, they can understand it.
Yeah, that's called Excel. In
Yeah,
Excel,
that's
you do
Like a
it.
bill handle? Yeah.
They should do it so you can like speak into it and they would like write it language.
Oh, that would be so
like,
good.
no, or to
If you could like take a picture of what you wanted to put into it.
If you stutter, then you don't
I'm gonna go to college and make calculators and things like that.
do it, and
That's yours, I don't. Or are you just letting him do it?
what am I on?
I was 0.6.
Okay, I don't think that's right.
Why is it going down now?
Well, think about what happens. If you have the probability of nobody doing it would be low, probability of everybody doing it would be low, but probably in the middle would probably be normal, wouldn't it?
So the highest number, no, wouldn't the highest number be?
It's probably going to be going up, have a little.
My highest number was 2.
That's what I thought, because it's closest to, 2 out of 6 is
My highest
closest
is
to 0.37.
My highest is 0.32.
Yeah, how'd you get 2?
No,
Oh,
that's
no, no, no.
That's 200% chance.
In the 2 slot, it was my highest number.
Oh, I understand you now.
Yes, 22.
What is it? Allie?
I don't know.
People need help, so they take
It's
the
like
flex pass and
players
it's
as
down return it.
I'm planning to get it this whole time, I just will never get it back. So he probably does it when he wants his friends to come.
Yeah, he's like,
When the window, he's like, I got the hook up.
he stopped me and was like, hey, you want to come play cards with me at Mr. Murphy's house?
I'll sell you a flex pass for $1.
It's a black market for flex pass, right?
Yeah, only Mr. Murphy.
I only use it for food though, Mr. Murphy.
My flex teacher, his name used to be Mr. Murphy, but then we got a new flex teacher.
Then he got married.
No, my flex teacher,
Now his name is
his
Mr.
first
Bonnie.
language is not
No,
English.
Mr. Murphy's from Oprah.
That's the same with mine. I miss Gita and
Oh, that sucks. I
You're all
hate
nice
this.
there, Mr. Murphy. One,
Yeah.
Last one that I have to show you to make a histogram.
don't mess
What is that?
Bar trap. Bar trap.
Bar trap.
Finished. High
Like
five.
Instagram.
On Instagram, straight flex. I am starving. Anna, did you know they're stopping me from taking salsa now?
There we go.
This
Finally.
lady talked to me.
Yay.
No.
All right. So here's what
I
happens.
didn't do stealing.
Bend it.
We now have an L1 and an L2. And what we're going to do, well, first of all, what's the probability? These are all of our answers. In your answers in your L2, you have some decimals in here. Do you agree? Looking at your calculator, what's the probability of getting at most 2 successes?
32%.
32 plus 2?
Yeah.
Hold on.
Or is it,
What do you mean?
so it would be like 50.
Plus 2 plus 2 plus
Think about what that's asking you. The probability of getting at most 2 successes. Well, getting at most 2 successes, well, that means I can have, oh, it didn't show up. I can have 0 successes. I can have 0 successes. I can have 0 successes.
So that's 20.
I can have 1 success, and I can have 2 successes. What do I do with those 3 percentages then? I have to add those up. This is one of those things where they're going to ask you at most, at least, it should be close enough.
It's like 60.
Okay. The probability of getting at most 2 successes, well, it's going to be 0.006. 0.62 plus 0.220 plus 0.323.
Oh, at most.
At most, okay?
It's like.
At most, there could be at least, exactly, you
And then
know,
over
just
all of them?
overall, no, it's not, these are your percentages. These are your percentages, these are your decimal equivalencies, okay? So right now, we have data in our X column, and we have data in a Y column. We're gonna create what's called a histogram, basically it's a bar chart. In order to do that with these funky fractions and decimals, we need to adjust our windows. So let's first of all set it up. Let's go to second table set, because we're going to turn on a stat plot.
Ooh. It's what?
Okay? You want to turn your first one on,
On.
Wait,
and then you're going to move down to type.
Second one.
The second one.
Oh, I thought it said second table set.
Did I say table set? I meant stat plot. I'm sorry. I hit stat plot.
So we want it on.
Yeah, we want it on, and I want to turn on the one that looks like a bar chart.
The third one.
The third one. And then hit enter.
When is it the first
And
one?
wait.
And then you have to click that.
Like history.
Well, before we do anything, you're going to have to change your window.
Oh, here it
I have
is.
it as 0.
So,
Your window is going to be probably all sorts of messed up. So I want you to realize what your data is giving you. Your data has X values between 0 and 6. So make your X windows between 0 and 7. Okay? Your scale, going left to right, just go by ones. 0, 1, 2, 3, 4, 5, 6, 7. Okay? Your Y minimum. We obviously have no negative value, but I like to see just the actual X axis though. So I'm just going to set my Y minimum at negative 0.1. I'm going to put my Y maximum at 0.5 because I don't think there was anything greater than 0.33, was there?
Yeah.
And then I'm going to have my Y scale, each line going up, if you will, at 0.1. It takes a little bit of time to get used to of setting these windows, but as you play around with it, it's not that bad.
No, mine is.
Oh, ugh.
Yeah, that happened to me too.
Wait, now what do you do?
Maybe it's the X.
He goes, it's not that bad.
Huh. Why did mine look all like that?
mine look like that too.
Huh.
That is wrong.
Because it looked fine on my regular calculator. Let's see, so let's go back to my. That should be right.
No, it's a smaller.
We're going on a trip.
Why is it doing that? Mine's
Wait.
one. Because I did mine on my regular calculator and it looked fine. Oh, we didn't do this. I'm sorry, my bad. We have to change, see where it says frequency?
No.
And underneath stat plot? Right now yours is defaulted to 1. Scroll down to that and type in L2. We want to do L2, so you have to hit alpha.
No, it's second too.
Oh, sorry, excuse me, second 2.
What does that represent?
It's, what table are you going into?
Ah, there it is.
And now we should see it.
Mine like shows up and then it shoots through the arrows. I see it.
You probably have something in your Y equals table. Go to your Y equals and clear it out.
Oh, I have something.
Yeah, I mixed it up with them.
You
I
just
made
cleared
the
all
white
your
mask,
lists.
too. I
Sorry.
made the one.
How come you left early?
Okay.
It should look like that then. Does everybody have something that looks like that?
Oh.
Okay. That's what a histogram looks like then.
What do we do with this?
I'm just showing you how to do it because eventually you're going to need to know how to make those.
Okay.
That's all.
So, the question then, what was the whole frequency thing?
The frequency thing is just looking at, normally in a histogram you're looking at how many times data was hit, but we're telling it to go to the Y values that we create. That's all. So when you think about regular bar charts, you would do like 8 times. There are 7 people between the ages of 0 and 5. There's 8 people between the ages of 8 or 6 and whatever. So your frequency is how often it occurred on the left side. For this was grouping in here, and that's how you would set those up. That's what that means. We're just telling it to go to look at the Y values instead. And it does this. We do this quite often with these histograms in here, because then now you can see, is your data skewed left, is it skewed right, is it normal? We'll get more involved with that over the next couple of days. Okay?
No, it's skewed left, skewed left.
Oops. So as we get going into this a little bit further in the course of the next few days, over the course, or like between tomorrow and into Friday, we're going to start doing a little bit more of our own testing, a little bit more of our binomial experiments. Tomorrow, we're going to take this and look at actual problems themselves, like word problems, and figure out how we can create a model, and it's really is it's quite simple to figure out. But what I want you to do tonight is I just have 4 problems for you. Okay? And don't think of it, oh, wow, he's looking at us 4 problems, it's going to take us 7 hours. It shouldn't. What I want you to do is in that, from page number it was, it's 742. So it'll be on page 742. I want you to do numbers, I think it was 18 and 19, 14 and 15, 18 and 19. What you're doing is in 14 and 15, you're calculating the probabilities that if you flip a coin, I forgot how many times. If you flip a coin 20 times, how often, what's the probability that you'll get a 10, or 10 heads? What's the probability you're going to get 11 heads? And it's not 10 out of 20. It's not that skewed. You use this binomial idea by going with success and failure. In 18 and 19, it tells you what is the probability of guessing A, B, C, or D on a 30-question multiple choice test. So if you have 30, your, what does that mean? Your end value is 30, because there's 30 pieces in the sample, and you're guessing 1 out of the 4. What's the probability you're going to be right? It'd be 25%. Probably you're going to fail is 75%. Then you just work through that binomial and to find those values. And then we'll build out of this more tomorrow. Yes, sir?
Are we gonna have to make a histogram for any of these?
Not for tonight, but I wanted you guys to see how you make the histogram.
Yeah.
So that way, when we start doing a little bit more of it tomorrow, like you see there's some histogram component to it. I ask you to make a histogram, but you're going to be looking at the data set on your calculator. You know, can you rough sketch what it looks like? It's going to help us to be able to create these lists as we get into 12-7 next week at some point, because these curves, as you look at some of these histograms, are going to start to be norm. There's something called a normal curve. In a normal curve, half the data occurs on one side, the other half of the data occurs on the other.
Is that like a peak?
Yeah, and then within what's called one standard deviation, 68% of all data occurs there. Within 2 standard deviations, it's like 97% of all data, and so on. So you'll hear stuff. You might have even seen a math geeky T-shirt at some point in time. Because you're in like the 99th percentile, that kind of stuff. So if you remember when you guys were...
buy a shirt like that, and if you wear it to school, I will personally give you like $3.
Personally, my dad bought that in a pie shirt for Pie Day.
I would for that. He keeps trying to give me to wear it to school.
Why don't you wear it to school?
I don't know. It's like a neon orange shirt that says I was there. And it has all these math equations.
Awesome.
I want a math shirt.
Yeah, that's what we're looking at.
That's not